So energy is made in living systems through two major pathways. One is glycolysis, which takes a sugar molecule and goes through the process, and it makes a few molecules of ATP at the end of the day. When mitochondria got incorporated into cells and created for this complexity, the advantage they gave living systems is you get a huge boost in the amount of energy that you're making. So mitochondria are the more efficient way of making energy. They use oxygen and movement of electrons and create this gradient to make a huge amount of ATP at the end of the day. What this part of the test looks at is under baseline conditions, when your environment is adapted onto those cells, are you making energy with mitochondria through this oxidative pathway, or are you making energy through glycolysis, through the glycolytic pathway? And we get an integration of those two. The way these test results you can interpret is most individuals who are well adjusted and normal and in a healthy state, they can use both processes, right? They can use mitochondria and they can use glycolysis to do this. At the far extremes, individuals that are elite athletes, they haven't optimized mitochondrial functionality. So they really, through diet, exercise, interventions, and through long-term change in their energetic systems, balance this in a state where their mitochondria are used to make more of that energy versus glycolysis. Because again, mitochondria are the more efficient, energy resilient way of creating energy in our bodies. And so they have this optimized thing where glycolysis is low and mitochondrial energy is high. In individuals that are weekend warriors that eat well, do the things that they need to do, you see an equal balance. They can do mitochondria and glycolysis. In individuals that are compromised in unique kinds of ways, both of these systems either get compromised, so you're in this low range of you can't use mitochondria to make energy and you can't use glycolysis to make energy. And in certain individuals that may be compromised from their energy perspective, but are trying to adapt and their system is in the early phase of adapting, they actually see a suppression of mitochondrial functionality, and glycolysis, which is the inefficient way of making energy, takes over. And you see glycolysis go really, really high as a way to try to balance and create that energy that the system is starved for. And so this is the way to think about this energy balance. Are you using mitochondria? Are you using glycolysis? And can you optimize those in unique kinds of ways?